Greetings everyone. My name is Dr. P. Pavan Kumar and I am going to explain you the Ruby laser. This is a topic in case of lasers chapter in advanced engineering physics. And the major contents I am going to cover in this video is the introduction to Ruby laser, construction, working, drawbacks and applications of Ruby laser I am going to cover in this. Now let's move to the introduction part of Ruby laser. Ruby is the first and foremost laser and it was constructed by Maimon in the year 1960. And as I said, it is a first laser and it is an example for solid state laser, and it is a pulsed laser having very high output power. Pulsed is nothing but the output is not continuous, output is a discontinuous, and it is a 3-level laser system. And in this laser we are using a ruby crystal as an active medium, that's why it is a solid state laser. And ruby is nothing but it's a aluminum oxide, that's Al2O3 doped with 0.05% of chromium atoms. Now let's move to the construction. This is a construction diagram for the ruby laser which consists of this ruby rod. This one is a ruby rod, that's as I said, this is doped with aluminum oxide plus 0.05% of chromium ions. And actually aluminum oxide color is red. Now when we dope with the 0.05% of chromium, and the color of rod will become pink, and that pink color rod is used as an active medium here. And here for this rod, one side we will polish it fully and other side polish it partially. The fully polishing side will become completely reflecting surface, other side is partially reflecting surface. And place this one in a glass tube, this one is a glass tube, and that glass tube consists of a cooling arrangement, and this glass tube is surrounded by this xenon flash tube, and this xenon flash tube is connected to power supply. And this is the construction of ruby laser. And to produce any laser, 3 parameters are important. One is active medium, second one is resonant cavity, third one is pumping system or exciting system. So in case of ruby laser, what are these 3 parameters? You'll see. Active medium, already I told you, this Al2O3 doped with Cr3 plus ions, that is ruby rod, is an active medium. And resonant cavity, 2 mirrors or silver coatings, one side is fully, other side is partially. These two acts like a resonant cavity, that is 2 polished surfaces. And another one, pumping system. So how can we excite the particles here is by using xenon flash tube. So here we are using xenon flash tube as the pumping system or exciting system. This is the construction of a ruby laser. Now let's move to the working of ruby laser here. So here the total work is done by chromium. The chromium consists of 3 energy levels, E1, E2, E3. So before applying this one power supply, all chromium ions are there in the lower state, that is E1 state. Now when power supply is on, so xenon flash tube is giving a flashes. From that flash, the 5600 angstrom photons will be absorbed by the ground state chromium particles and they get excited to the E3 state. They will take a maximum energy and they will move to the excited state E3. And there is no speciality for E3 state, or we can call it is a short-lived state, and after 10 power minus 8 seconds, I mean after their lifetime, they come back to E2 state. So while they are moving from E3 to E2, they don't emit any photon, but they emit a heat. So we can call it as a non-radiative transition. Heat will be released. And E2 is a specialized state, that is what a metastable state means. Here the particles will be stayed for sufficiently long time. Here more number of particles are accumulated in E2 state, and situation is erased where number of particles in E2 state are more than the number of particles in E1 state. This leads to population inversion. And after reaching this population inversion, one particle will come to lower state spontaneously by emitting a wavelength of 6943 angstroms. And all this process is happening in case of ruby rod, that is fully reflecting and partially reflecting surfaces. The photon will go and hit with the partially reflecting mirror, but the energy is not sufficient, so it is reflected back. While that is coming back, that will stimulate one more particle in the excited state, come down, and they become two photons. And these two will go hit with a fully reflecting mirror and comes back. While coming back, these two stimulate two more in the excited state and they become four. And the stimulated emission continues because of the mirrors. What happened? Continuous reflections happens, and after getting sufficient energy, they come out from partially reflecting mirror, and that's taken as a laser, and that is a wavelength is 6943 angstroms is the output wavelength, that is red color. The output laser color is red. So here the stimulated emission, and here metastable state is important, and population inversion is also important. All these things makes the laser to come out from the partially reflecting surface. And this is the emission of ruby laser. And all these particles come down. In the meantime, the xenon flash tube gives a flash, and again they go to E3 state, and the same process will be continued. So one flash, one laser beam will come out. So output is not continuous here. And now see the drawbacks of this ruby laser. So as I said, output is discontinuous. We are not supplying the energy continuously. So obviously output is discontinuous. And another drawback is more amount of energy gets wasted. How? Means I'm going back to the working. Here heat energy gets released. So here in the process, in the construction, we need to have this cooling arrangement for that de-excitation. And out of the xenon flash tube is giving around 100% of energy, but out of that, the ground state chromium particles hardly uses 30 to 40% of energy is utilized for that, and remaining 60 to 70 unnecessarily heating this glass tube. So a lot of energy gets wasted in that. For that purpose, we are using a cooling arrangement. So that is another drawback here. So I am repeating drawback. First one, output is discontinuous and more amount of energy gets wasted in case of ruby laser. And still, even though drawbacks, there are applications with ruby laser, and this can be used for tattoo removing and can be used as a pointers in the presentations and all those things. This is the drawbacks and applications of ruby laser. Thank you very much. Happy learning. Thank you.